Hi, chapter 12 and 13, water and the minerals. I've broken this chapter, or this module 6, up into 3 videos. First, I'm going to talk about water and an overview of the minerals. Then there's another video that will talk about the major minerals, and then finally the last video about the trace minerals. So by the end of these 2 chapters, you'll be able to explain how the body regulates fluid balance, list some of the ways minerals differ from vitamins and the other nutrients, and be able to identify the main roles, deficiency symptoms, and food sources of both major and trace minerals. So we're going to start with water and the body fluids. So I think we talked about this earlier on in this the semester. Your body is made up of about 60% water. It's a little bit more for infants, and it's a little bit less for older people. Children need more, older people and women need a little less. And water has many, many functions, and I just put some little graphics here, but it carries nutrients around the body via the blood system. It also removes waste from your body, waste products. It maintains the structure of large molecules. It participates in numerous metabolic reactions. It's either where these reactions are happening, or sometimes water is the product of a reaction, or water is required to make the reaction happen. So it is very involved in metabolic reactions. It is a solvent. It can act as a lubricant. If these 2 bones just kept rubbing against each other, they would wear away. It can aid in regulation of body temperature, and of course it helps maintain your blood volume. So how long can we survive without water? Again, every body is different. So the average person, it could be anywhere from 2 days to 1 week. And it depends on a number of factors, not only how hydrated you were before you didn't have access to water, but it depends on your age, right? Children need Children need more, adults need less. Your current health status, of course, the weather, depending on whether you're outside in the middle of the desert and it's 120 degrees, or you're in a 70-degree, temperate climate. And also what physical activity you are involved in at that time. So, solvent, it can dissolve many, many things, amino acids, glucose, minerals, other things. Fatty substances can travel attached to water-soluble proteins. It is part of the cleansing process our kidneys are involved in. Waste, such as nitrogen from amino acids, can be dissolved in blood, and then they have to be removed to avoid toxicity. And we have our kidneys to thank for that, because they help filter out these wastes. When that urea is mixed with water, we get urine. And so that cleanses our body of those toxins. I already mentioned it is an active participant in numerous chemical reactions, whether it's an anabolic reaction or a catabolic reaction. We saw it in cellular respiration and condensation reactions. So it's involved in almost all chemical reactions. It's a lubricant and a cushion. So a lubricant and a cushion for the joints. It protects the spinal cord from shock. Our spinal cord is surrounded by cerebral spinal fluid. It keeps the optimal pressure in the eye. Amniotic fluid protects the fetus. The fetus is floating in the amniotic fluid. It maintains the fetus's body temperature, it allows the fetus to move around, and it protects them. And it lubricates the GI tract, right? Every time you drink something, we have some lubrication going on. It lubricates the respiratory tract and all the tissues that have mucus in them. Have water lubricating them. And it's a coolant. It helps maintain body temperature by sweating. So your body cools down when you sweat. So where do we find these body fluids? There are two types of cellular fluid. There's intracellular, which is inside the cell, and there's extracellular, which is outside of the cell. And that extracellular fluid could be in two places. It could be interstitial, which is this here, interstitial, also known as intercellular, and that's that fluid that surrounds the cell. Or, if it's not interstitial, it's intravascular, and that means it's inside the blood vessels. So those are the places you can find fluid in our body. 2/3 of all of our fluid is intracellular, and 1/3 of it is extracellular. So what happens when you don't get enough fluid? You become dehydrated, and your body has a number of different receptors that can sense these changes in your body fluid status. Your mouth might become dry, right? We have that thirst. And that usually when you have that thirst, you're already dehydrated because your thirst response lags behind your body's need for water. So thirst is usually the first symptom that you'll feel. And when you feel it, you're already on your way to being dehydrated. So here are some of the symptoms. Sorry about that. Dog's barking for no reason. So the dehydration symptoms, first thirst, like I said, you're already on your way to being dehydrated. Then you may feel weak, and then exhausted, and then delirious, and then death. I'm sure you've all seen the cartoon where you have a guy, and he's usually a guy, and he's crawling across the desert sand, and he looks up and he sees this, like a swimming pool or, a lake or something with, lots of water. And that's always, I think of that as he's in the delirium stage. He is seeing something that is not there. So, next stage is death. Water loss, these are a list of symptoms that someone might experience depending on the amount of body weight or body water that they've lost. So 1 to 2% of their body weight, they're going to feel these things: thirst, fatigue, weakness. 3 to 4, we have impaired physical performance, a dry mouth. 5 to 6%, you have difficulty concentrating. 7 to 10%, you could have spastic muscles or loss of balance, or maybe they'll collapse. And if it's not corrected, it can lead to death. So the other thing, if you're not dehydrated, water intoxication is also a possibility. It is rare, but it can happen. And this is an ingestion of 10 to 20 liters within a few hours. It usually happens to people that are exercising an awful lot or practicing a sport. And what's happening is that they drink so much that it dilutes their sodium concentration. And when that happens, they become confused. They can start with convulsions, and then death can also happen. And the recommendation, when you are exercising and you are sweating heavily, you want to limit your water intake to 1 to 1.5 liters per hour. And I did the math for you. That's about 4 to 6 cups or 33 to 50 ounces. So I put a picture of these 2 bottles of water. Those are the 16.9 ounce bottles. 2 of those equals about 33 ounces, so 1 liter. And that's what you should be drinking per hour. And anything over that, you risk the possibility of water intoxication. We can also get water from other places other than water. Even though water is 100% water, we can get water from the food that we eat. And pretty much all foods have some sort of liquid or moisture in them, except these 2. The only 2 things that don't are oils and sugars. Even something dry like crackers or cereals or pretzels, they still have some percentage of water in them. So, of course, what do we see up here closer to the top? We see, of course, liquid things. That makes sense. But also lots of fruits and vegetables, strawberries, watermelon, lettuce, right? Fruit juices, yogurt, apples, grapes, oranges. So lots of fruits and vegetables at the top, and then more of your processed foods down here at the bottom. Talk about water balance. We want to, you want to take in and put out the same amount, and your body does an excellent job at doing this and maintaining your fluid status. So if you drink about 550 milliliters to 1500 milliliters per day and get another 700 to 1000 milliliters from foods, your body actually makes water, right, with all those different reactions that are happening when we make energy. We have fluid that's given off, so 200 to 300 milliliters of fluid per day. That equals, if we add these all up, that equals about 1450 to 2800 milliliters per day. Well, when we look on the negative side, your kidneys, you produce about 500 to 1400 milliliters of urine. We sweat 450 to 900 milliliters per day. When you breathe, you're exhaling some carbon dioxide, so you're getting rid of a little bit of moisture when you breathe, so 350 milliliters per day, and that's a little bit more than a cup. And we lose some fluid in our GI tract when we have a bowel movement, and that's about 150 milliliters per day. And when we add these all up, look at that, it equals, they're about the same. So your body does an excellent job of maintaining your water balance. You don't even have to think about it. So what are the recommended intakes? Again, it depends because every body is different. It varies based on your diet, how active you are, what kind of temperature you live in, and how's the humidity. So these are some of the things that, can vary, so we can't really give everyone a specific number they need to drink. So we have an adequate intake for water, and it's about 2 to 3 liters per day. And so that's somewhere between 8 to 12 cups per day. I don't know, I think I grew up with the drink 8 cups of water per day. And, I'm not young, so it's been like that for a while. But so now it's 8 to 12 cups per day is the adequate intake for water. Just going to do a brief overview of the minerals. And here's a comparison. I'm going to do a comparison of the minerals and the vitamins. So minerals are inorganic. What does that mean? That means they are indestructible. They cannot be destroyed. Where vitamins are easily destroyed, minerals are not. They can't be destroyed in any way. Their absorption depends on many factors, where when we talked about vitamins, their absorption and handling depended on their solubility. One way that they're the same is that their bioavailability varies based on numerous factors, and they are both involved with different nutrient interactions, where sometimes an absorption of too much of something can limit the absorption of another nutrient, so they interact with other nutrients. Like I said, they are unable to be destroyed. They're naturally occurring substances that plants and animals cannot make. So if you cannot make them, that means you must eat them. And where do they come from? They come from the soil. They come from the ground. They come from the earth. And what you grow in the dirt that is there, it absorbs those minerals that are in the dirt. So, inorganic minerals are not destroyed by heat, air, acid, or mixing. When it's a mineral, once a mineral, always a mineral. You can crush it, but it's still going to stay a mineral. They will remain in the body until your kidneys excrete them, or your body via your stool. Cannot be changed into anything else. So vitamins can be made into other things, but minerals cannot. They can be leached out of food into the water when you're cooking. So if you're cooking a vegetable, let's say you're boiling it, the mineral will come out and it will remain in the water. So if you use that water for something else, you may get that mineral back. If you use it to make a broth, or you use it to, put on your pasta. Lots of different ways to keep those minerals. There are 16 minerals that are necessary in our diets, and several others may be needed in very small amounts. They're very similar to vitamins in the fact that they have, some of them are readily absorbed, and others require some sort of carrier to get them in or to be transported around the body. If you have excessive minerals, they can be toxic, just like some of the vitamins that we talked about. And they have their bioavailability, their ability to be used by the body varies depending on a number of different things like binders. These are things that combine chemically with the minerals that prevent their absorption. So there are two that are listed in your textbook, but there are others. These two are phytates and oxalates, and they're found in food. And what happens is that they bind with calcium, iron, or zinc, and they do not allow calcium, iron, and zinc to be absorbed by the body. That's phytates. Oxalates, same thing, except it does it only for calcium. So it binds, the phytates and the oxalates bind with these minerals and then do not allow them to be absorbed, so they go out in the stool. Also, if you have excess of some minerals, it can affect how other minerals are absorbed or metabolized or excreted. So a big one is the higher your sodium intake, the more calcium you excrete through your kidneys. So again, a high sodium intake could result in osteoporosis in later years because of that. I already mentioned the mineral content of food depends on the soil and the water where the food is grown. So, if you have a garden in your backyard, every so often you have to amend the soil. You have to put some nutrients back into it because the plants that grow take the minerals out of the soil and get into the food that you're growing. So you need to replenish those minerals. And the mineral content, of course, is going to be affected by any kind of processing that it's done. So it's not that the minerals are destroyed in the processing, but they can be stripped and removed if certain things are taken out of the foods when they're processed. There are two types of minerals. There are the trace minerals and the major minerals. And it does not mean that the trace minerals are less important or that the major minerals are more important. It is solely based on the amount that you need per day, and also the amounts that are found in our body. Trace minerals are needed in smaller amounts, less than 100 milligrams per day, and we find them in small amounts in the body. And major minerals are needed in larger amounts, greater than 100 milligrams per day, and are found in larger amounts. For example, iron is a trace mineral. Women need 15, 18 milligrams per day, but a major mineral like calcium is needed, 1,000 or 1,200 milligrams per day. And here is the minerals in a human being that weighs 132 pounds. So they might have about 1,100 grams of calcium in their body. Calcium, phosphorus, potassium, these are all some big numbers, 210, 150, 90, even 30 grams of magnesium in your body. And then we look at these trace minerals, and these are just some of them, but these are 2.4 grams, 2. We get into, 200ths of a gram. So those are the reasons why we have trace versus major minerals. Major minerals are needed in larger amounts than your trace minerals.